Engineer Romil Kumar is an energy auditor with extensive experience in the energy sector. He has served as an Assistant General Manager EGM at the Bakra Bias Management Board BBMB in Delhi, where he was responsible for overseeing energy management and auditing functions. His expertise includes conducting energy audits, implementing energy conservation measures, and ensuring compliance with the energy regulations. Engineer Rohit Kumar earned his BTech from IIT Roorkee with distinction, a diploma in marketing management, a certified lead auditor of quality management system ISO 9001, a certified lead auditor of environment management system ISO 14001, certified JDED assessor for MSME, Ministry of Micro, Small and Medium Enterprises from Quality Council of India. In addition to his role at BBMB, Engineer Kumar has been involved in various energy-related projects and initiatives, contributing to advancing energy efficiency practices. His work has had a significant impact on energy management strategy in the region. Engineer Kumar is also a member of the Bureau of Energy Efficiency (BEE) and has been recognized for his contributions to energy auditing and management. His professional journey reflects a commitment to promoting sustainable energy practices and enhancing energy efficiency across various sectors. Welcome, Romil sir. Please proceed by your presentations.
Thank you. Thank you, Dr. Srinivas. Thank you very much. So, good evening, everybody. First of all, I'm very thankful to Professor B.K. Kanujia, the Director, NIT Jalandhar, Dr. Srinivas, and other renowned faculty members of NIT Jalandhar. Dr. Srinivas has spoken too much for me. Thank you very much. So today we'll be discussing regarding cogeneration of electricity, its benefits and applications. So basically, cogeneration, it has got significant potential in the present day power sector for transforming the present energy supply system to make it more sustainable. Because, and this cogeneration has got influence mainly in thermal power plants and nuclear power plants. Now, in thermal power plant, the coal energy is converted to heat in the form of steam or hot gases, and then heat is then converted to mechanical energy. Heat energy then converted to mechanical energy in the form of rotating a shaft, and this shaft is directly connected to the rotor of the generator, by which the mechanical energy is converted into electrical energy. In this process, normally 20 to 45% of the heat is converted to electricity, and rest is rejected to the environment as a waste. Our intention is to harness this particular heat energy into some usable form, so that the efficiency of overall plant is improved and less fuel is used to generate electricity and at the same time heat energy, which we require for some definite purpose in the industry. Now, by using the combined cycle generation at thermal power plants, we could improve this particular efficiency to 55%. That is 45% to 55%. and rest of the, I mean, the rest 45% energy is wasted. But cogeneration reduces this loss further by utilizing the heat which was otherwise being wasted for industry, commerce, and for heating of the houses. Now, basically, cogeneration of electricity, which is also called combined heat and power, it is a process where both electricity and useful heat is produced from a single fuel source. And this results into improved energy efficiency because we are utilizing the waste heat. We are reducing the wastage of energy into the environment. This ultimately leads to substantial cost savings on account of fuel and reduced environmental impact because we are allowing less heat energy to go into the environment. The key concept for cogeneration of electricity is that instead of releasing the waste heat from the power generation into the environment, we capture this heat energy and utilize it for heating, cooling, or any other industrial purposes which we can devise and provide at the beside the generation plant. So it is efficient power generation because cogeneration system generate electricity while simultaneously capturing the waste heat, or we can say that simultaneously capturing the heat and utilizing it which otherwise was being wasted. This process significantly reduces the energy waste and enhancing the overall efficiency of the plant. But for this, we have to devise methods for heat recovery and its utilization. Because the captured heat is utilized for various applications. What can be the applications? Heating, cooling, or any other industrial processes which can run with the heat energy, or which can convert the heat energy into some useful energy, so that the energy utilization is maximum and reliance dependence on the other heating systems is reduced. Now, if we see the importance of electricity, now electricity is the most important critical component of the infrastructure which affects the growth of any country. Because for the growth of any country, we need agriculture. Agriculture growth is there only when electricity is there. We need industries run with the electricity. We need corporates, they run with the electricity. Because infrastructure is essential for the sustained growth and that needs electricity. We are generating electricity by two kinds of sources. One is coal, hydro, natural gas, oil and nuclear power. These sources or these fuels are called conventional sources. Then there are some limitations, or we can say there are some environmental impact of this, the environmental impacts of generation with the conventional sources, whether it may be coal or hydro or natural gas, oil or nuclear. So we have to shift our energy generation to non-conventional sources, which are wind, solar, agriculture and domestic waste, because the impact of generation from these non-conventional sources is less, pollution is less, and that's why we are we have got a shift to these non-conventional sources of energy. Now, demand of electricity has been growing at a rapid rate, and it is expected it is growing, it is increasing day by day. It is expected to grow further in the years to come. At present, India is the world's third largest producer of electricity and third largest consumer of electricity. The national electric grid in India has an installed capacity of 384.116 gigawatt as on 31st of December 2024, the latest figures available. And this is with the help of two types of sources categorized as renewable sources and non-renewable sources. Now, renewable sources are the which cannot be exhausted even after the continuous utilization. Sun, wind, tidal energy. And renewable and the non-renewable sources means which are exhausted after their use, that cannot be reclaimed. Now, as far as installed capacity of power stations in India as on 31st of December 24 is concerned, the total installed capacity is 462.001 gigawatt. Out of that, coal has got 212.349 gigawatt, lignite has got 6.620 gigawatt, gas has 24.818 gigawatt, then diesel has got 0.589 gigawatt. And the total thermal installed capacity is 244.376 gigawatt. Nuclear has got 8.180 gigawatt. Now, thermal and nuclear. In the production of electricity from these two power plants, lot of heat is generated and lot of potential is there to harness this heat, which is otherwise go waste. And by this, we can increase the efficiency of generation of electricity at the power plant. And that is the need of the time. More energy, less fuel. As far as now, renewable power capacity, renewable RES includes small hydro project less than or equal to 25 megawatt. Because I tell you here that hydro projects are included in both renewable and non-renewable, and they are being controlled by two different ministries. These small hydro projects, they are MNRE, Ministry of New and Renewable Energy, and larger projects are controlled by the Ministry of Power. Now, SHP, small hydro project of less than or equal to 25 megawatt, they are in the RES. Then biomass power, urban and industrial waste power, solar and wind power. And the installed capacity as on 31st of December 2024 is for wind, it is 48.163 gigawatt. See how much it is, 48.163 gigawatt. Solar is 97.864 gigawatt. Biopower, in which the biomass is 10.728 gigawatt and waste to energy is 0.619 gigawatt. Why I'm telling you all this regarding renewable? Because this cogeneration production can be integrated with the RES production through a green energy corridor, and then the combined power can be integrated with the grid. because these are all distributed energy sources. They cannot be individually connected to the grid. We have to make some, or we have to devise some method by which the power is clubbed together and then integrated to the grid at one point so that it can be controlled. Now, as far as thermal power plants and hydropower plants, I tell you from the control of grid point of view that thermal power plants, they run to feed the base load. Means once the machine of the thermal power plant is on bar, that will not be disturbed. That will not be switched off according to the demand. That will remain on bar. Now come to hydro. Hydro machines feed the variable load because the load on the grid goes on changing from 00 hours to 24 hours. From 00 hours to 2400 hours. So the loads are varying. So we are switching on the machines or switching off the machines depending upon the load, and that is done with the help of the hydro machines. The reason? Obvious, because thermal machines take at least 3 to 4 hours to come on bar when it is hot standby, and 7 to 8 hours when it is not hot standby. So by controlling the grid, we cannot wait for 3-4 hours even when the machine is hot standby to come on bar, whereas hydro machines takes only 10 minutes to switch on or only 5 minutes to switch off. Therefore, the variability during the day is met with the help of hydroelectric power plants or hydro machines. Now this wind and solar, although they are very good as far as environmental concern is concerned, but there were some issues regarding uncertainty, variable dependence on the weather, variability. So they are good source, and we have devised a method to integrate with the grid through green energy corridor. So with this cogeneration shall also be integrated with the RES power. Now this cogeneration systems for producing electricity is the same. The method is same. We are generating electricity, but here the steam or the heat energy, is captured and utilized for some useful purpose. Overall generation efficiencies can reach up to 90%. Normally 80 to 90% is achievable. And one more thing, that the electricity which is produced by the cogeneration plant is used locally, because we cannot take away the heat energy to far away, to far places. So this heat is utilized within the plant or near to the plant. It means we are not required to transport or transmit our energies on the transmission and distribution networks to the long distances, so that T&D losses are also small, because the T&D losses are proportional to square of the current, whatever current we are flowing on the transmission lines. So because the distance shall be less, so I square R shall be less. So by this cogeneration offers energy savings of 15 to 40%. Overall of energy efficiency can be achieved from not efficiency, cogeneration energy savings of 15 to 40% is achievable when compared to the supply of electricity and heat from conventional sources. Now, cogeneration process merges the production of electricity and usable heat, and which substantially reduces the carbon emissions and energy costs. Now, diagram of cogeneration system components. Basically, in the conventional thermal power plant, we have got two systems, prime mover and generator. That is turbine system and generator system, alternator. But in cogeneration plant, we will be having a third system which is called heat recovery system. That is heat exchangers. So prime mover, the turbine system, the prime mover such as the gas turbine or the steam engine, it is the heart of the cogeneration system. It drives the generator for ultimately production of the electrical energy. Then generator. Generator converts the mechanical energy from the prime mover, from the turbine, into the electrical energy, which can be used on site, that is within the plant, or it can be integrated with the grid. And then the third system is heat recovery system, because the heat is also produced in this process. So heat recovery components, which are normally heat exchangers, they capture and utilize the waste heat from the prime mover, producing the useful thermal energy. In this diagram, I will show that this is the fuel consumption. It is the steam is given to the engine or turbine, then generator, it is connected to the generator, electricity is produced, and electricity is given to the building or the facility and integrated with the grid. Then it has got other system also, that the heat exhaust gases go to the heat recovery unit, water is flown into the there, then heat exchangers, and steam or hot water goes to the other useful purposes in the buildings or the factory or the facilities. Now this was regarding concept of cogeneration. Now we come to the what are the advantages of cogeneration. The advantages of cogeneration include the higher energy efficiency, lower energy costs, reduced greenhouse gas emissions, increased energy security by reducing the reliance on the grid supply, and potential for economic incentives due to its sustainability. Because in the cogeneration, we can achieve efficiency of 90%, and the 8 to 10% is waste losses are there. So with the 100% fuel, power is 40% and output heat is 52%. So if we discuss the individual benefits, then increased fuel efficiency. Because in the cogeneration process, less fuel is required to produce the same amount of electricity and heat, which otherwise would need more fuel for producing the same amount of electricity and heat. Then increased energy efficiency, because in the cogeneration process, the waste heat is being captured and utilized. It means the wastage to the environment is less. Therefore, the energy efficiency is increased. We can increase the energy efficiency up to 80% to 90% compared to the conventional system, because in the normal conventional electricity generation, the energy efficiency is normally 40 to 50% at the maximum. Then we are utilizing less fuel and producing heat and electrical energy both. It means resource optimization is there. Reduced energy costs, and all these benefits we have discussed here, that ultimately lead to the reduction of the energy costs. The cost of energy, it means the cost of electricity per unit shall reduce, because the amount invested or incurred in production of that particular unit is reduced, so the bill will also be reduced. So lower operational cost due to the reduced fuel consumption and better heat utilization. More efficient is the system is in creating electricity and heat. Therefore, the energy cost shall reduce. And when energy costs are reduced, the energy bills for the industry or the homeowners shall also reduce, because the efficiency has increased and energy waste has reduced. And when the cost saving is there on account of energy bills or electricity bills, then the owner of the factory or the owner of the plant can allow the business to expand. That is, he can invest this particular saved money in some other operations. Then economic advantage, because all this lead to the economical advantage for the industry. Then impact to the environment. The question arises here, what is environment? What is environment? Environment is basically everything around us with which we are interacting. Everything around us with which we are interacting. And the components of environment are air, soil, water, all flora and fauna, all living beings. They are all components of environment. And thermal power plants, including that nuclear power plants, they have very high impact on the environment, because the outcome of the activities of these at these power plants is affecting air, water, soil in the surroundings, all flora and fauna even in the environment. So we have to reduce this impact of electricity generation on the environment. Now, in the cogeneration, for a fixed amount of or for a particular amount of electricity and heat, we require less fuel consumption. So it means we are releasing fewer greenhouse gases. It means we are contributing less pollution to the environment. It means we are contributing to a cleaner environment. And this is a big advantage, because the less greenhouse gases means a happier and healthier environment for all. This is our social responsibility. Our social responsibility towards environment is that we manage our activities in such a way that the impact of the outcome of our activities is minimal on the environment. And the cogeneration activity is one of that we have ultimately devised a method by which the impact on the environment has reduced or will reduce whenever it will be familiar or it will be common in the industry. Then environmental impact, this cogeneration contribute lower carbon footprint and ultimately reducing the impact on the environment. And this environmental reduction of the environmental impact will have a direct impact of the climate change. So it means climate change mitigation is also achieved. Because cogeneration plays a crucial role in mitigating the climate change and promoting a greener energy future. Am I audible to you? My connection is okay? Anybody who can tell me?
Yes, sir.
Okay, good. Thank you. Now, grid independence. Now, if every facility will draw power from the grid, the load on the grid will increase. It means we will have more generation from conventional sources. And if some of the facilities use methods to produce their own energy, it may be electrical energy or it may be heat energy or it may be utilization of the heat energy, then the grid independence will reduce. And moreover, this independent production for its own facility is having a more stable or reliable power supply, because the grid can fail, grid can have some disturbances, and then this independent supply from cogeneration will provide electricity. And this may be very important for some of the industries which need very reliable, highly reliable power supply, because they don't want any cut during the process of their manufacturing, such as glass industry, the rubber industry, tire industry. They need continuous power. There should not be any power cut, otherwise the process, if the process is stopped in between, a lot of material is wasted, because they are using the material in the molten state, and if the power goes, that particular material is not producing anything and that is wasted. So they need very highly reliable power supply, and that can be achieved through cogeneration because it is their own supply. They are not dependent on the outage of the grid. Now, cogeneration's role in decarbonization and emission reduction. Now, renewable energy integration. I told you that this cogeneration can be integrated with the renewable energy sources like solar and wind, providing a more resilient and sustainable energy system. Then, emission reduction goals. Cogeneration plays a crucial role in achieving the global emissions reduction targets by improving the energy efficiency and reducing the dependence on the production of electricity with the help of fossil fuels. Then carbon neutrality is also there. By reducing the emissions and leveraging with the renewable energy sources, cogeneration contributes to the transition towards a carbon neutral energy future, and which is the need of the time. Now, reliable and resilient power supply. because this cogeneration is on-site power generation. It allows businesses to generate power on-site, reducing the reliance on the traditional power grid supply and ensuring a more reliable energy supply, especially for the processes which need highly reliable supply, such as glass industry, the rubber industry, such as tires industry. They need continuous supply. Then they can't afford power cut even for a minute. Then backup power. In case of outage of supply, the backup can be taken from from their own supply, which is the cogeneration supply. That is, in case of the grid outage, cogeneration facilities can provide a reliable backup power source, and this minimizes the disruptions due to critical operations. This reduces the disruptions to the critical operations which require continuous supply without fail supply. Then energy independence. Cogeneration promotes energy independence by providing a self-sufficient source of power, reducing the vulnerability to the external factors, because there may be so many factors, bad weather, storms, earthquakes, by which the energy supply may fail. The distribution system may fail during a flood. So any disaster can disrupt the supply from the grid. Should the facility suffer due to that? To avoid the heavy losses which may occur, so they need highly reliable supply. They need energy independence from the grid supply, and that is possible if they are having a cogeneration facility also. Then diversifications. Now, the CHP plants, that is the cogeneration plants, offer flexibility by integrating with the resources, enhancing the energy security and sustainability. Okay, now we come to the another topic, which is where we can utilize, or where we can apply this cogeneration system in the industries. So first of all, we will discuss, we can apply this cogeneration system in several sectors in several sectors. First, we will discuss where we can use this in the agriculture sector. So heat produced during the CHP process can be used for the greenhouse heating, because CHP provides sufficient and reliable heating, and that can be utilized for greenhouses, optimizing because this greenhouse heating optimizes the crop growth and extends the growing season. Normally we say it that temperature, by controlling the temperature, by creating a temperature controlled environment, we can optimize the crop growth and extend the growing season, and that is possible with the help of the CHP. Now, livestock housing. This cogeneration supplies heat for the livestock housing also, for creating the temperature controlled environment for the animals, because that needs heats. So instead of because nowadays in the conventional method, what the people are doing, they are providing heaters in the livestock housing. But instead of that, the heat from the CHP can be supplied to this particular facility, and that will be used for lifestyle for supplying heat to the livestock housing, that is improving the animal welfare and enhancing the productivity. Then irrigation pumps. Then CHP system provides reliable electricity for irrigating the fields, because the pumps can be fed from CHP system, ensuring the consistent water supply for the crops, increasing the agriculture growth. Now we come to another, that is the manufacturing sector. Application of cogeneration in the manufacturing sector. Because process heat, manufacturing plants utilize cogeneration for the process heat, such as steam for sterilization, or we need steam for drying any equipment or any system. So this process heat can be utilized for and the electricity electricity produced is used for the machines, for running the machines. That process heat can be used for a wide range of manufacturing processes, from food production to the chemical synthesis, where a low temperature environment is required in the industry of food production. Then electricity generation. Cogeneration system produce electricity, reducing the reliance on the grid and ensuring energy security for manufacturing operations. Then cost optimization of the manufacturing sector. Then CHP systems lower the energy costs and improve the overall operational efficiency of the plant. It increases the profitability of the manufacturing processes, and ultimately the profitability of the business is increased. Now we come to another sector, that is cogeneration, the power generation sector. It is increased efficiency. When we are using cogeneration in the power plant, we are increasing the efficiency. So cogeneration plants improve the overall efficiency of the power sector by capturing and utilizing the waste heat, which ultimately leads to reduction in the fuel consumption for production of the same amount of electricity and heat. Then diversification. This cogeneration plants offer flexibility, because the electric energy can be integrated with the renewable energy production, enhancing the energy security and sustainability. Here I will elaborate this word energy security. Energy security means when we are producing electricity, then we want continuous production. We don't want any interruptions. So our system is secured only when it can withstand some disturbances in the system. If there is some disturbance in the system, our system should be able to withstand that. It should not go. It should not fail. So our system is secured only when it can withstand small disturbances in the system. And when we are integrating our cogeneration with the renewable energy sources, because I told you earlier also that We cannot directly integrate our small power with the grid. We have to integrate with the other sources so that a substantial amount of energy is integrated with the grid at one particular point of integration. So by integrating with the renewable energy sources, we are increasing the energy security and we are increasing the sustainability of the plant. Then reduced emissions. In the power sector, we are otherwise generating a lot of emissions, and we are releasing those emissions to the environment. But here in the process, the cogeneration plays a crucial role in lowering the greenhouse gas emissions, contributing to the environmental sustainability goals and reducing the impact of generation of electricity on the environment. Then cogeneration, the nuclear power industry. Waste heat utilization, because the nuclear power plants can use the cogeneration to capture and utilize the waste heat for distinct heating or industrial purposes. Enhanced efficiency. Cogeneration increases the overall efficiency of the nuclear power plants by utilizing the heat produced during the electricity generation. And reduced environmental impact, because by maximizing the energy utilization and lowering the waste to the environment, we are ultimately reducing the environmental footprint of nuclear power plants. In the hospitality industry, heating and cooling, we can use the heat which would otherwise have wasted for the heating and cooling purposes. In the hospitality industry, then cogeneration provides reliable and cost-effective heating and cooling for hotels, for resorts, and other hospitality facilities. You can use it even for the hospitals if they are located nearby. Then energy savings. Cogeneration systems reduce the energy consumption and operational costs, enhancing the profitability of hospitality businesses, because we will be less dependent on the grid supply. Then environmental sustainability. Cogeneration lowers the emissions, contributing to a more sustainable and responsible hospitality industry. It means we are reducing the environmental consideration for the hospitality industry also. Then for healthcare, hospitals rely on the cogeneration to provide reliable power for medical equipment and heat for sterilization, heating, and hot water. Because in the hospital, sterilization is a very important activity. Heat, the closed or the environment, the temperature controlled environment by heating is a requirement of the hospital, and hot water is also a requirement of the hospital. So all these facilities, all these can be provided through cogeneration in the hospitals. Then education system or education facility, universities and colleges, they use cogeneration for heating and cooling buildings, reducing the reliance on the grid supply. Then they use electricity for powering the laboratories and supporting the campus activities, that is electricity to the campus buildings, hostels, etc. Then for data centers, then data centers leverage cogeneration for their high electricity demands and cooling requirements, ensuring continuous operation and reduced energy costs. So these were the applications in different sectors. Now we come to what are the emerging trends in the cogeneration technologies. First is digitization. Advanced digital technologies like artificial intelligence and machine learning are transforming cogeneration, optimizing the operations and enhancing the efficiency. Integration. Cogeneration is increasingly integrated with the RE sources, creating a more sustainable and resilient energy system. And then decentralization. Small scale cogeneration systems are becoming more common, enabling the decentralized energy production and reducing the reliance on the central grids. These type of systems are no doubt integrated with the connected with the grid, but they are connected with the grid through a net meter. They are generating their own supply, utilizing their own supply. In case of any problem in their own supply, that is the cogeneration system, they can draw power from the grid. They are integrated because their system should not disturb if the cogeneration system has some problem or some requirement of maintenance. So that is integrated with the grid. But normally they are using their own power. If they have got some extra power, only then that will go to the grid. And in case of any problem in their own system, then they will draw power from the grid. Now, cogeneration, the energy transition, the entire scenario of energy is going to change. Decarbonization, that is a requirement of the time. Decarbonization, that key technology in reducing the carbon emissions, because we are very much concerned regarding the carbon emissions. So this is one of the methods by which we are going to reduce carbon emissions. Then renewable integration combines well with the renewable energy sources. Energy efficiency, we will be able to maximize the energy utilization, lowering the costs, lowering the bills, increasing the profitability. Now, what is the future? Cogeneration's role in the future of energy sector. Sustainability. Because we want to improve the sustainability of the system. This cogeneration is having a critical role in reducing the emissions, flue gas emissions, etc., and improving the energy efficiency, and by which the sustainability of the energy sector will improve. Then innovation, ongoing research and development will contribute to improve efficiency, because this is one of the methods by which we can increase the efficiency, but this will give some other such work. This will be this will give a way or the path for the researchers to develop other methods to improve efficiency, and no doubt it will lead to economic growth, because it will create good jobs supports economic development through energy savings. Then what are the challenges before us? For
Sir, excuse me, sir. Sorry to disturb you.
Yes, please.
Sir, 6:30 validatory is scheduled later. They have exam on 7 o'clock, 7 to
Okay.
8. Please consolidate, sir, so that questionnaire we can start.
No problem. No problem. No
Thank
problem.
you. Thank you, sir.
Definitely. Definitely. So what are the challenges before us? There is initial investment. Then technical complexity, how to devise methods to capture heat and utilize it. And regulatory requirements, how to fulfill the regulatory requirements, because we need to comply with the environmental and safety requirements, safety regulations. Here I will tell you that as far as safety regulations are concerned, we have to refer to CEA, Central Electricity Authority regulations, which is named as CEA Measures Relating to Safety and Electric Supply 2023. And for comply to environment, we have to study, that is Environmental Protection Act 1986. Then there are some limitations of this cogeneration system, because when we devise a system, it cannot be 100% perfect. There are some cons that must be considered when looking at the cogeneration. What are those? Not an intrinsic energy source, because cogeneration is just used to make another energy sources more efficient, because it is not a intrinsic energy source by itself, then not suitable for everyone. Cogeneration is only applicable to the areas that have a need for heating or cooling and electricity. It can be costly. Although cogeneration can save you money on your energy bills, the installation cost for some systems can be very high. Then not always environmental friendly, because some pollution or some impact is there on the environment if even we are using cogeneration. So I feel this is all for my presentation. So if there is any question, you are welcome. So no question. So thank you very much, Dr. Srinivas, for giving me time for the presentation. Thank you very much.
Thank you, sir. Thank you for giving the lecture and delivering the talk on the cogeneration. Especially, you highlighted the power generation with the process heat. That means with various examples like nuclear power plant, thermal power plants, or etc. And this lecture definitely it is useful to understand the concepts of this integration, especially the that's extension to the thermal power generation to get the different multiple outcomes like power, process heat, cooling, etc. Thank you, sir, for accepting first of all and then delivering this lecture on this topic related to this power generation.
Thank you. Thank you very much.
Thank you so much.